Okay. Okay. Hello, everyone. My name is Leonard, and I'm going to guide you through today this lecture. Thank you for everyone to participate before the weekend. I think it is evening in India, so good evening to everyone who's joining from there. Before we're going to start the lecture, I would just quickly want to briefly talk about some organizational aspects. So our guest lecture will have like 50 minutes to first presentation, Olaf Kolkman. Then we will have 10 minutes for some Q&A, and whoever wants has some time to answer some Mentimeter questions. Briefly, to introduce our guest today, Olaf Kolkman is an executive level advisor and spokesperson of the Internet Society and strategizes and reviews technical and policy issues for more than 2 decades. Olaf is actively engaged in the intersection of internet technology, society, and has a deep knowledge of internet technical aspects, and currently is a member of the SIDN, where he is part of the supervisory board. And also a treasurer for the Global Forum on Expertise in Cyberspace. With that being said, I hand over to Olaf. The floor is yours.
Hello, everybody. It's very nice to be here. Very happy to talk to you all. If everything is right, you see me big on the screen. If that is not the case, then go to the bottom part. You see my name somewhere like there, or maybe there. I don't know where it is. And it has 3 dots. If you click those, then there's a text like pin for me, and then you can enlarge the screen for me, because I'm going to use this video for the slide deck. So let's dive into that slide deck. Today, we're going to talk about the Internet Impact Assessment Toolkit. It's a description of an approach to look at policy proposals that are made with respect to the Internet. That's the long and the short of it. During that, I will explain a little bit how this came about and how this relates to the Internet architecture. So what I hope when you walk away from this course is that you have an idea about how these critical properties relate to the underlying technology, and that the underlying technology and the way that people work with that internet, with that technology, are almost fundamental to the way that we think and approach the internet and its governance. So next slide, I hope. Let's see. I want to talk a little bit about the Internet Society. We've talked enough about me just a minute ago. 30 years of expertise, always deep technology, and I slowly moved into basically what is internet governance and internet policy. So I work on that division between policy and technology and try to be a translator, and that's what I do today. I work for the Internet Society. I'm going to show you a couple of slides with QR codes on them. Those are links that you can follow. I will be sharing the slides later, so you don't have to be on your phone now and frantically trying to follow those links. Anyway, I'm working for a charitable organization called the Internet Society, and our vision is an open, globally connected, secure, and trustworthy internet for everyone. And when we say for everyone, we mean for everyone. We are organized in members, chapters, and organizational members. We have 152,175 members. Becoming a member is easy because it's free. You don't have to pay. You become part of our community, and you can follow our work. And sometimes we do public consultations, and then we reach out to our membership to get their impressions. A number of those members are organized in chapters or special interest groups. Chapters are usually localized, and I made a snapshot of the map where you see the subcontinent, and you see a number of chapters in your region too. So again, if you want to join us, you can also subscribe and become a member of a local chapter, and basically talk and advocate with like-minded about the open internet. We also have 79 organizational members, organizations that help build the internet, but also some of the big tech firms are an organizational member. They pay a little bit of money to be a member. Those are the only paying entities, but it is by far not enough for what we do. We are an independent organization, and most of our funding comes out of .org domain names. That is something we have an organization called the Public Internet Registry, and they sell domain names, and that provides our income. And with that income, we try to get internet to everybody. And that internet needs to be resilient, affordable, reliable. And we try to educate people. We try to make policy interference when policies can be created to be more favorable for an affordable, reliable, and resilient internet. And we basically defend that open internet so that people everywhere have opportunities to create, innovate, and build their own communities. And of course, when you have that internet, we also want that internet to be safe and secure and support the technologies that allow you to be safe and secure, and have a policy environment that allows you to be safe and secure when you go online. That has to do with pure hard cybersecurity, but also with transparent and accountable governance online. In last year, we did a bunch of things. Let's just say it. So we're divided in the Internet Society and the Internet Foundation. The Internet Foundation does things by training people, giving out funds, those type of things, training trainers, and you can see the numbers here. We have granted about 1,000 grants for a total over 63 million across 120 countries, truly global organizations. And on the Internet Society side, you can see what we did in terms of influencing policy. As I said, you can become a member. Very simple. Scan the QR code, get to a landing page, and there you go. Go off and do that. I would appreciate if some of you would do that. But I'm not here to basically promote the organization. I'm here to talk a little bit about the internet way of networking. I hope I don't speak too fast. I presume that Leonard will shout if I'm not audible or if my slides are not visible. So I'll continue. Internet way of networking. The internet way of networking is really about what are the properties of the internet that make it work. What are the properties, and what is the sort of architectural and conceptual framework that makes it work. And that's what I want to spend the next half an hour a little bit more on. There are many ways to talk about the internet architecture. One of those ways is in terms of a model. That model here is what we call the hourglass model, where on the bottom of the hourglass you have a lot of infrastructure. Those are networks, the networks by which you now connect, for instance, via your mobile phone to the internet, or the network that is in your university or in your office that eventually connects to the internet. I'm connected here to an office network too, and that office network is then connected to another network, and that other network is connected to multiple other networks. And by having a mesh of networks, and mind you, there are 77,000, a little bit more than that, of those networks around, they form the internet. And each of those networks has different businesses, uses different technologies. Some offer you 5G connectivity for mobile phones. Some will offer you fiber optics, a fiber optic connection or a cable connection or something else to connect to the internet. Some will not even connect users, but connect other networks among each other. They, for instance, would build submarine cables, submarine fiber cables by which internet traffic is transported. So independent networks that make their own business decisions, but what they do is they exchange traffic among each other. And that traffic is called the Internet Protocol, is Internet Protocol traffic, IP. What you see in the hourglass are little bits of IP. That network of networks provides you a global perception of one big infrastructure. Global perception of one big infrastructure that is basically unique. That is that you know when you use the internet or when your application uses the internet, they have no idea about what those individual networks are. You connect to the internet, somebody else connects to the internet, and suddenly you can make connections. So that's the top of the hourglass. That's where the applications and the users do their business, where they derive the value of the internet. And the magic that ties that network of networks together is the waist of the hourglass is the IP layer, the internet protocol layer. So that's a conceptual model to think about the internet, a network of 77,000 plus networks that connect and basically provide you a perception of end-to-end connectivity when you're using applications. Let's see. We know that the internet is incredibly successful. The internet, as you basically perceive it, you get online, you use a service, an application, or your social media, or you read in the newspaper, or you're doing your banking business, or something. And the internet is really successful, but the question is why? What are the critical elements and the properties that made the internet so successful? What led to its success? And why is it that over the last, 40, 50 years of its existence, it's still continuing to evolve? And it's still able to adapt to new circumstances. Remind yourselves of COVID. Maybe this is a little bit of a Western perspective, but most people, when they before COVID, were basically binging Netflix all the time. They were sucking in traffic. They were watching YouTube videos. Everything came into their direction. At the moment COVID happened, people started doing the things that we do now. I'm producing video and you're looking at it. Traffic goes out of my network into the world. And when people started meeting on Zoom meetings and team meetings, that changed the whole traffic flow of the internet. And the internet could just deal with that. And that's basically the healthy evolution that you have. So at the Internet Society, we sat back and said, what are those aspects that are important for the internet? What are those critical properties that will make that the internet depends on? And when you start changing those critical properties, what you lose? And so the critical properties are the things that we absolutely want to maintain when we think about the internet and its evolution. Because if you take them away, the internet will become a little bit less internet. It will become a little bit more closed. It will become a little bit less secure. And at some point, it might be, maybe people know this game of a Jenga tower. You know, these are little wooden blocks where you put blocks on top of each other and then suddenly you pull one, the whole block collapses. Same with critical properties. You might take out a critical property and put it back on top, a little bit modified. But if you do that too often, at some point, the tower will collapse and we might lose what we perceive as the internet. So we've written this down, Internet Way of Networking. This is the link to the document. Again, you will get the slides and the material so you can look this up. What we did is we provided 5 critical, or we defined 5 critical properties of the internet. Those are an accessible infrastructure with a common protocol, an open architecture with reusable building blocks, a decentralized management and routing system, common global identifiers, and a technology neutral purpose network. So what does an accessible infrastructure with a common protocol mean? Let's see, maybe I should start a little drawing now. There we go. If everything is right, you will see a new screen. So the internet, as I just said, is a network of networks. 70,000, and they're all interconnected in some way. Within a network, people might use all kinds of technology that they see fit. That doesn't matter. As long as at the edges of that network, they provide IP connectivity to their neighbors and to their clients. Yeah, and the clients, they sit here. For instance, here's a mobile phone. This is the simplest picture of a mobile phone that I can think of. That mobile phone over there basically talks to the rest of the internet by just sending IP packets. They're delivered inside of this network. This network delivers it to a next network. That network delivers it to a next network. And at some point, it pops out and it goes to some service provider, for instance, Twitter or something. And that might be in a data center. That might be, you know, in many different places. But what we see here is that we've built a network that uses a common protocol, namely the Internet Protocol. And by having that common protocol, it also becomes very easy to become part of the internet as a network provider. If you want to build a new network, whether that's at home, whether that is as a business, or whether as an internet service provider, the only thing that you have to do is build a new network and then connect it to one neighbor. Once you've done that, once you made one simple connection over here, you have become part of the internet. That's fascinating, isn't it? Well, that's that first over there, that first critical property, an accessible infrastructure with a common protocol. You can access the internet. It speaks IP, it has one common protocol, and by connecting to it, you become part of it. It's accessible. One critical property. And you only need one contract. You only need a contract with your direct neighbor. If you connect to the internet, you pay your internet service provider and you become part of that internet. You don't need to have a contract with my service provider or with me to interchange traffic across the world. Only one connection, only one contract. You can, of course, connect to multiple other peoples and have contracts or understandings about traffic delivery, but that's basically the point of it. The internet is an open architecture of reusable and interoperable building blocks. There is not a big blueprint that says this is the technology of the internet. And this is the way that we should build it. In fact, that doesn't exist. There is no blueprint of the internet. What there is are ideas, small building blocks. Like I hope everybody has heard of Lego, the little plastic building blocks which you can use to build houses or models of the Death Star or what have you. The point is you have very little standardized building blocks like the TCP/IP suite or the security modules that you can use to build applications. Like the World Wide Web technology. Those are all building blocks. They're defined in technical specifications by the Internet Engineering Task Force, which is one of the standards organizations, or by W3C. But for the internet, the ITF makes those standards. ITF means Internet Engineering Task Force. Completely open organization, has produced over a couple of thousands of these building blocks. Open software, sort of the same category, open architecture, open building blocks. People can combine, reshape, and recreate things. So the internet is constantly evolving. Part of this and the technology neutral general purpose network is that it provides you permissionless innovation. When you invite something new, you don't have to ask permission. When Satoshi invented the blockchain, he didn't have to ask permission to put the blockchain on the internet. He just did that. The internet architecture is open enough to do that. Back to this picture that I showed a minute ago. Networks, 70,000 of them. That network clearly doesn't have a centrum. There's no central location. It's highly distributed, and there's not one person that turns all the knobs in order to make connectivity work. Now, all these networks act autonomously to build a view of the world and build connectivity. There's not one single point of control in this network. That is quite profound from a technology point of view. And for us, that's then also a critical property. I know this is rather technical. Some people might scratch their head, but that's where we are. Common global identifiers. In order for this all to work, we need some uniqueness in the system. We need identifiers that are persistent, and we need names that are persistent. The identifiers are what we call IP addresses. There are two types, IPv4 and IPv6. I won't go into the details, but whenever you encounter such a number, an IPv4 address is usually 4 numbers with a dot in between, 192.168.178.2. That might be an IP address. Those IP addresses need to be unique when you enter the internet. Every computer that connects directly to the internet needs to have a unique IP address. And we need to have some common understanding among each other that those are all, we're looking at the same thing. There's some uniqueness, and that when you get to a place that has a certain identifier, a certain IP address, that you end up at the right place. Now, we're very bad with remembering these identifiers, these IP addresses. So we also have something that is called the domain name system. That's a second class of identifiers, and those deal with names. Like www.internetsociety.org is a domain name. So common global identifiers, IP addresses, and domain names. Important critical properties because it allows us to find each other when we are on the internet. The final critical property is that the internet is a technology neutral general purpose network. It has not been built to do one thing very well. It has not been built to do video very well, or it has not been built to do messaging very well, or telephone calls, or blockchain, or it has not been built to do AI very well. It has been built to just deliver connectivity to everybody who needs it. Has been built as a general purpose network, and that has served the internet very well. It has the internet has constantly been evolving to adapt to the needs of its users, and the users have constantly, in terms of applications, developed applications that would use the internet as it existed in the day. I have a gray beard, I realize, and I do. Internet became available in my youth. I was in my 20s when the internet really became popular, and I had access to it in my house. I had a personal computer, and that came with a modem, and that modem had a connection speed of 16 kilobit per second. 16 kilobit per second is more than 1,000 times less than your mobile phone connectivity is now today. You couldn't do video on that. Downloading something took ages. Downloading a video was basically impossible at the time. But still, around that time, people were working on the YouTube infrastructure because they knew that the internet would evolve, and they bet on that feature. General technology neutral general purpose network, which is also permissionless. You can just deploy without having to ask. I cannot see if there's any question. Leonard, are there questions in the chat perhaps?
Yes, there are questions at the chat, but should we have them now or later?
Yeah, let's see because this is a nice point to make it to talk about questions.
Okay, so then one of the questions that we are having is about what sort of threats, or what is the biggest threat that the internet, or the biggest danger the internet is facing in the next 5 years. And then some of our users are also very interested in IP addresses, and in particularly about, I guess, the security of an IP address. So what makes an IP address secure or strong, or maybe, on the contrary, not so strong. So more, the internal working of the infrastructure. And then also, maybe what challenges does this infrastructure face since it's evolving to the needs of the users? What are maybe unwanted influences or malign influences that could impact the security of other users?
Those are all incredibly good questions. So what are the biggest threats to the internet? Let's start with that. If I were to summarize that, I would say fragmentation. I see fragmentation as the biggest threat that we have to the internet if we don't watch out. And fragmentation means that when I'm in India, I perceive a different world than when I'm in Europe, in China, in the US, in Latin America. It doesn't matter. We have, people have been writing about the Chinese internet and the US internet and maybe a European internet. I think that would be an incredibly bad idea. So islands of connectivity that perhaps use the same technologies, but are firewalled off from the rest of the world. I think that is a threat. I think that would be a very bad thing. That could happen on the application space. We see some of that happening already. A blocking of certain services that happens all the time. But it could also happen on the application, on the network layer, so on the lower end of the hourglass. And then we lose all connectivity. And some countries do this all the time. They have shutdowns. It's something that we follow at the Internet Society. We monitor which countries have complete shutdowns, which disconnect themselves from the Internet in order to, for instance, protect their school exams. That happens because they're afraid of cheating. Now, the reason why they do this is a good reason. They want to prevent cheating in exams. But disconnecting from the internet comes with humongous cost. And I think that fragmentation of the internet itself, the network of networks, will come with humongous cost. Fragmentation on the application layer will come with humongous cost, but can perhaps be reversed as long as we still have the internet as a layer. So for me, that's the biggest threat. Then the security of an IP address. Let's see. I was showing this this graph earlier. All these networks, all these individual networks, like this one here or this one here, receive blocks of IP addresses. Now, IP addresses themselves have no real security features. The IP protocol, the way that we communicate to each other, that does have security features. You have to constantly think, how do we build in security in the protocol? So if you set up a connection between this side and this side, or this telephone and this server, doesn't really matter, then traffic is flowing. And in the very classical internet, that would all be in the clear, and all the networks that are on path could listen into that traffic. So that was a problem in the internet. That problem has been solved over the last decade. After the Snowden revelations, people set out to work to basically provide encryption on all the traffic that crosses the internet. We're very carefully looking at how can we make traffic confidential by applying encryption. And this comes back to this open architecture with interoperable and reusable building blocks, because that allows these security building blocks to build in. Now, if it comes to how this traffic finds its way over the internet, it's a process that is called routing. There are still issues that we need to be solving. And another issue that we are trying to solve, collectively, it's a collective action problem in a sense, is the fact that IPv4 addresses have ran out. There are only 4 billion of them, and everybody, everybody has need for addresses, so they have been distributed. And nobody in the internet can use the same address twice, so we have haves and we have have-nots. That's a bad thing. But fortunately, over 30 years ago, people invented IPv6, and IPv6 has not 4 billion addresses, but 340 trillion times trillion times trillion addresses. That's a lot of addresses. And what we're trying to do on the internet is deploy IPv6. Deployment is now currently at about 40%. So this is a transition that we as humanity, digital world, are going through, and it might take another few decades. Challenges, indeed, we're using encryption. People don't like that because, for instance, law enforcement cannot look into the traffic. Other other issues is, you need resiliency and diversity in this whole network. And having that resiliency and diversity is important. And what we see is forms of consolidation. Those mainly happen at the application layer, where previously you would have a service that would be run by a small firm. That firm will now put everything into the cloud. And if you look at the cloud environment, that's heavily consolidated. So that's another thing to watch out for. I hope that answered the questions for now. So let's go back to the slides. It takes a little while, but here we are. You can imagine that if you look at the problem in if you look at a proposal, then these critical properties will usually not turn up something that is, really severely impacting the internet. Mainly things that impact the way that applications interact might not always impact the internet itself, and therefore not those critical properties. But having an internet alone, an unfragmented internet alone, is not very useful. So we have an additional layer for that. So the critical properties are needed for the internet to exist. But when we have the internet, we also want to have that internet have want to see that internet offers us something. And the way that we've been thinking about this is by looking at what are the terms that people use that talk about the internet. Well, you heard terms safe, free, secure, open, those type of terms. And it happens to be that our mission is an open, globally connected, secure, and trustworthy internet for everyone. And whenever people talk about open and free or open and safe, you can always map those words back to these goals that we have for the internet. We want it to be open. We want everybody to be able to connect to it. We want to have it secure so that people cannot abuse it on a technical layer. We want to have it trustworthy so people can safely use it and are not cheated out of their money or scammed or abused or, all those type of things. So these goals are enabled by certain things. And so in an assessment, we would look at the critical properties, and we look at these goals and the things that enable those goals. And I will quickly go over those in a few minutes. And when you look at a proposal like that, and you can do this, if you think there is no impact on the existence of the internet whatsoever, you can skip the whole critical property thing. But you can still look at proposals or developments through the lens of this of these enablers and assess whether a proposal is problematic for the internet. So it provides you basically a methodology to understand whether a proposal would have an impact on the internet and on the goals that we have for it. And this is more or less the same, this sort of impact assessment is more or less the same as an impact assessment that we would do for environmental damage when we have a building project or a law proposal. Usually, those type of things would be looked at and see what, if we have a proposal, what would be the environmental impact, or what would be the financial impact. Impact analyses happen all the time. So an open internet allows people as an organization to mix and match technologies. You might hear you recognize this a little bit from the independent building blocks, but this is a little bit more. It's also about applications and the use and the ease of connecting those. And what enables that is unrestricted reachability. So when I create an app in the Netherlands, I can reach users in India. When you create an app in India, you can reach users in South Africa or in Latin America. And in order to have an open internet and have all these capabilities, you also need a certain level of available capacity. Not only capacity on your network, but also capacity in learning and development and tools and skills. We want the internet to be globally connected, both at the internet, but also at the application layer. So at the bottom of that hourglass and at the top. More connectivity is better. Easy and unrestricted access is better. This is the reason why we also think that IPv6 should be deployed, because when you have IPv6, it's easier to get connected. And because we're globally connected, we need collaborative development, management, and governance of the internet. And some of you might have heard that this year there is a review of the World Summit on the Information Society. This was a summit that was held 20 years ago, and in which the governments of the world agreed that multi-stakeholder governance of the internet, which is collaborative development, management, and governance in essence, was the way forward. So we're very carefully looking whether that consensus actually holds within the UN, because we believe that it's incredibly important. We want the internet to be secure. There are too many data leaks. Devices can be hacked in very easily. Services are hacked every day. We want an internet that is secure, so data is protected, the integrity of information is protected, applications and services are protected. That links to trustworthiness, because trustworthiness and security basically give you an aspect of safety. Trustworthy means that your infrastructure or whatever we do is reliable, it's resilient, it's available, but it also means that there's accountability in management of applications or in the management of the agreements that we have, that companies work in an accountable way, that the decisions are made, decisions about users, whether their content is blocked or not, are made in accountable ways. Blocked or moderated, I wanted to say. And then, of course, there's a reasonable amount of privacy there. So this is a lot of talking. This is not all the details, but we've developed a toolkit. In the link earlier, I gave you a little bit of I gave you a link to the Internet Impact Assessment Toolkit that explains how the toolkit is used. But the way that we usually do this is we take an issue, a change, or a policy development, and we look at it first through the lens of the critical properties. That establishes whether there is an impact on the internet at all. If that is the case, those give rise to real concerns, and those are relatively black and white. But if you start to look through the lens of the enablers for an open, globally connected, secure, and trustworthy internet, then you might find conflicting conflicts in your assessment. Openness might actually lead to less trustworthiness. By having an open email system allows people to send spam. So that reduces the trustworthiness of the internet. And if you basically disallow spam or put filters in place to disallow spam, you make the internet a little bit less open. But that is a conversation to have when policy is created. So understanding these trade-offs is important. And this type of toolkit will basically put a spotlight on the trade-offs. So this is the way that you use these ideas. So I hope that in the past, 35 minutes or so, I've given you a little bit of an idea of first this impact assessment toolkit, but also a little bit on how it's grounded in the technology of the internet. That this is not just a way to talk about the internet, but it is informed by its architecture and by the way that people think about it and the way that people manage and organize. Finally, I want to give you a pointer. Again, the slides will be shared. We have just made, and like really just made, a number of videos that talk about these critical properties and their impacts. They're actually very, very good. They should appear or have appeared today. This is all very new on our Internet Society Learning platform on YouTube. This is where you can find free videos that will help you understand things about the internet, things that might help you with advocating for an open internet. So should you want to do that, have a look over there. And now I'm looking at the time, and I see we have 10 more minutes. And 10 more minutes is exactly what we wanted to have for Q&A. Leonard.
Okay, first of all, thank you so much for your lecture. Really, really enjoyed it. It was highly interesting of how the internet works. I really enjoyed that. We have a couple of questions actually. First of all, though, we have Dr. Sriram here, who's from DCCI and is part of organizing the school with us. I will briefly unmute him so that he can ask his question himself, I think. 1 second. Okay, Dr. Sriram, you could ask your question, I think.
Yes, hello. Very interesting talk, Dr. Olaf Kochman, and very happy to know about the different aspects, and you put it very nicely together. My question is that due to various reasons, many parts of the internet are going dark, okay, because of increased encryption and tighter encryptions, quantum resistant, and also because of various tools like the chats and various ones. So which makes it a little dangerous to draw the balance, because many parts of the internet are not visible. They are within select groups, makes it difficult for law enforcement agencies. You take typically the protests that are going on in Nepal now. They're using a tool that was unleashed on them, like BitChat, that works only peer-to-peer on Bluetooth. Now, strictly speaking, that's not part of the internet, but like that, many parts of the internet are also going dark. I mean, dark web was there for a very long time, but in general, what do you have to say about this phenomenon in which people are forming their own clusters and groups, and the government cannot really control or switch off? So if there are mischief makers, they can end up doing a lot of things without getting caught. Okay. And even spread disinformation, sway the elections, cause protests, riots, do a lot of crime activities and all. Use the internet for that. So it's going dark is not really a very healthy thing, isn't it? Completely dark. Yeah.
Yeah. The term "going dark" has a lot of weight. The dark net is usually seen as a place where criminals go, but might not necessarily be that. But I don't want to dismiss the underlying part of your question. That is, as law enforcement, you're basically in a sovereign country, you are responsible for upkeeping the law. And if individuals use encryption, then it is harder to directly look at the content that they are spreading. And this might cause all kinds of issues that we are deeply aware of, spreading of fake news, not having control over those type of things. So the policy aspect that you are referring to is very well understood. On the other hand, when we look at the internet, it's the global infrastructure. And when we deploy technology on the internet, like encryption technology, it needs to work for everybody, and it needs to provide a relatively safe transmission method for the individuals that use it. And encryption is needed in order to maintain confidentiality. We have seen that big actors that have a place on the internet have been reading all the information that passed through the internet. And so that's the reason why strong encryption has been deployed on the internet. The only problem is that that strong encryption needs to work globally. And if we make an exception in the technology so that people, the government from Belgium can read the traffic, but the government of the Netherlands cannot, then of course we have a collision. If we create weaknesses in the technology that everybody uses, and the government of Belgium decrypts, has a backdoor as the only one, then I'm sure that all the other nations will want to have the same backdoor. And the backdoor will be the same because it's the same technology across the whole world. So the issue that we are dealing with when we look at this type of global infrastructure is that this exceptional kind of access is very hard to engineer. What we know and notice is that law enforcement, at cost, I agree, often still has capabilities to get to the information that they need. But it's hard. I fully agree with that.
Thank you. I had a...
I'm going to be very clear in this, or very transparent in this. In the Internet Society, we are very strong proponents for the use of encryption on the Internet, because overall, we believe that it will make people more safe, more secure. They can do their business, they can talk to their friends. And yes, there are also awful things happening on the internet that we all want to solve. But no good answers.
Just one small question here, that with increase in IoT devices, Internet of Things, right? That's where this IPv6 and all also will come in handy, because there are going to be proliferation of IoT devices, because most of the things are smart. I mean, they can connect. Whether it's your wireless mobile, your AC, washing machine, so many things are all smart now, aquarium also, everything. So you see that there will be a proliferation of devices. Now, the old standards around these devices which are there, the manufacturers and so on and everything. So internet is going to be taken over by not just human actors, but also the entire machine and maybe the artificial intelligence as well. So any comments on that?
I missed the very last sentence. Can you repeat
The very last is that internet is now going to be not only human actors, but all machines and artificial intelligence, right?
Oh,
Also,
so yeah,
large parts.
yeah, no, you're completely right. But then again, I don't think that the internet was ever completely for humans. There's always been device-to-device interaction on the internet. So that doesn't surprise me. What concerns me is that whenever we connect more stuff to the internet, we really have to think about A, is it necessary to be on the public internet? And B, how do we care for the security of everything that is connected to the internet? So when we talk about the things, if people have smart homes with smart lights and smart thermostats, do they need to be connected directly to the internet? Or is a hub and spokes model where those connect to a little, gateway box and the gateway connects to the internet? Isn't that a smarter model? And I think that we have to constantly think about these type of things. What do we connect to the internet? What don't we connect to the internet? Not everything needs a global connection, in my honest opinion. And that specifically goes for things.
Thank you.
My pleasure. I have time for more questions, but I leave it to Leonard to organize this a little bit.
Okay, we have like one or two more questions actually, so we can definitely time-wise briefly address them from my point. One of them is it was asked whether is like do you know, or like, do you have an idea of how the internet is exactly going, or most likely going to develop in the next decade? So are there any forces where you could preview already how this is going to look like? Another part is that is the internet in some way also insecure based on I mean, I think you touched about that on that before, but is the internet in some way also insecure based on the design principles on how it is built? So, and is there any way to really address that? I think you briefly mentioned the spam factor for emails, for example. Yeah, that's what I see currently in
Let's start with that second question. Is the internet insecure? Yes and no. When the internet started, the common global identifiers like IP addresses and the DNS, the domain name system, the names, were basically insecure. Any on-path attacker could change communication flows. Any on-path attacker could mess with the mapping between a name and an address. So that if you want to connect to www.internetsociety.org, you would end up with www.evengineer.net or something. Over the past, 2 decades, we have done our best to deploy DNSSEC. I don't want to talk about myself, but that transformation has been part of the journey of my life. I've been developing the protocols, I've been developing the software to do that, I've been developing the tools to enable that transition in the most frictionless manner. And I think we came a long way to secure the DNS. The routing system, similarly, the routing system is incredibly insecure. the way that the routing system works is that everybody is shouting at each other. 77,000 networks are telling to their neighbors, if you want to reach that address, you can send traffic to me, I'll forward it. That's what they all say. And so there's millions of these messages saying, if you want to reach that place, if you want to reach that place, send it to me, I'll handle it, I throw it off. That is gossip, and it's incredibly insecure. Anybody can say at the beginning of this shouting match, I have this set of addresses. So I could claim to be an Indian ISP and then say, I own this space, just send everything to me. This is exactly what happened a couple of years ago with what we call the Pakistan YouTube incident. Pakistan tried to block access to YouTube for its users, and they used the routing system to implement that block, and they made a mistake. And the whole world thought that YouTube was in Pakistan. So all the traffic intended for YouTube went to Pakistan. Pakistan YouTube incident, look it up on Google. We have fixed that. We, the community, the routing community, have fixed that issue. We can now protect against that. Not everybody does that, but we can do that. On the layer of the applications, the fact that everybody could listen in has been solved by deploying encryption. And we just had a discussion about that. And in general, we're constantly evolving the internet to make it more secure and more efficient. So if you ask me, how is the internet going to develop in the next 10 years? My answer is, I actually don't know. There are many possible paths to which the internet could develop. It could fragment. We could see new technologies being, not new technologies being introduced, but technologies evolving to something new. I think that is the path that the internet will take. It's an evolutionary model, but what I'm sure of is that the internet will evolve. The internet as it is today is a different internet than 10 years ago and is a different internet than 20 and 30 years ago. It constantly evolves. So I hope I answered the two questions. Leonard, over to you.
Thank you so much. I have one more question, which I think I will bring up because I think it's like of an especially relevance to the students that we are having here. And the question is simply, do you have probably any advice on how to progress in the cybersecurity field that is attached to your topic? Yeah, as the wrap-up question for our students, if you have any advice probably on that.
Engage. It sounds silly, but engage. Start with going to that YouTube platform. We have for our members, so the YouTube platform is learning is open, but we also offer a number of courses. One of them is an internet security course. Security is something that you learn by doing, at least in my experience. If you are trying to do cybersecurity in a company, there are many people who you will be competing with. If you are trying to do security in networks, that's not a very sexy topic. So less competition, perhaps. That type of security is very important and is needed. Follow trainings, experiment, build stuff, build networks yourself in your lab, build a lab. A lab doesn't need to be expensive. You can build basically a small lab with a bunch of with a few Ethernet switches and a couple of Raspberry Pis. That might still be very expensive, but you don't have to have racks of information to do experiments. Talk to people. Getting a career anywhere and specifically in the internet, depends on basically networking. Contribute to projects, be seen. So if you want a career in anything, make sure that you, make sure that you are seen and contribute. I think that's my learning.
Okay. I also don't see any other questions currently.
Oh yeah, I see. Sorry. In ethical hacking, I see something there. There are very good books on hacking. Let me quickly look here whether I have it in my bookshelf. No, I think there's a book called The Art of Hacking. Forgot the name. But there's very good books. Learn to program. Try to understand how things work very deeply, and just experiments. Download Wireshark and look at all the fields that you see passing by in communication. Try to understand what they mean. Read RFCs, and when you hack, be ethical. Don't enter stuff that you're not invited to. That can get you in very, very, very big problems. Read on what ethical hacking is and what the boundary conditions are. You want to be careful. So experiment, but experiment on your own stuff.
Okay. I don't see any further questions currently. So therefore, yeah, I think I wanted to thank you for your lecture, very interesting lecture. I learned a lot personally. I'm sure our students did as well. Thank you for your time.
My pleasure. My pleasure. I'm looking at the conversation in the chat about ethical hacking. Yeah.
Okay.
A lot of interest there.
Yeah, I think maybe I don't know, maybe we have time like for one single last question, since given the interest in the cybersecurity aspect. Is there a platform where you could learn that as a wrap up, and then yeah, for the day?
Come again? No, I don't know a good platform, but I see also that people want to close the session. I would say Google for go to fora where these type of things are discussed. The /dot. It's not particularly a hacking forum, but it's a place where people discuss technology. In order to understand hacking, you first have to understand programming and protocols. So play with programming, play with protocols. That's my tip. It's about understanding, curiosity.
Okay. Then given the time constraints that we have, unfortunately, I thank you very much, Olaf, for your time and your patience for answering all the questions. Yeah, thank you. Have a nice afternoon later, nice weekend, and thank you for your time.
My pleasure. My pleasure.
Thank you.
Bye-bye.
Bye. Okay. I give you guys 20 minutes for a snack, and then we will see each other in Dutch time at 4 and 20 minutes again. Thank you so much. Bye.